So we are looking at rational equations and inequalities. So today we're just going to focus on the equations. You guys were just graphing rational functions, right? We are drawing those graphs based off all their information. The next step is how do we solve equations with these types of things. So let's say, for instance, I gave you this equation and told you to solve it. All right, we have two options. We can either keep the fraction, get everything together, and get a common denominator so we can put it all into one big fraction. That's option number one. Option number two is get rid of the fractions. All right, either one will work for solving these equations. I don't care. What do you guys prefer? Do you want to put it all together and get one big fraction, or do you want to get rid of all the fractions? We're split 50-50. How about I show both ways? I'll show both ways and then we'll decide what we like. How about that? Okay. Option number one. If I'm going to put all these together, we have to have a common denominator. Okay? This one has a denominator 2, this one's x minus 1, this one's just 1. So if these are going to have a common denominator, what does this fraction need? It needs x minus 1, right? And if you multiply it on the top, you have to do it on bottom as well. What does this one need?
2x minus 3.
Well, we're going to multiply the 2, so it'll make it. So we'll just multiply a 2 on top and bottom. This one is currently over 1, so it's going to need everything. It needs a 2 and an x minus 1. All right, so if I FOIL, we get 2x squared minus 2x and minus 3x would be minus 5x plus 3 over 2 times x minus 1. I'm not going to multiply out the bottom. This would be a 4x over 2 times x minus 1. This one I get 2x times x minus 1 over 2x minus 1. Oops. All right. Not beautiful, but we can work with it. So we add like terms. These have the same denominator, so we can add these together. So we get 2x squared minus x plus 3. Denominator doesn't change. I need to bring this over, so I'm going to subtract it over. We can distribute that 2x. All right, if I want to subtract that fraction, what do I need to do with my negative? Make it plus and distribute that negative. So, my 2x squareds cancel. Negative x plus 2x, so I get x plus 3 over 2 times x minus 1 equals 0. Okay, so all the work I did was just so that I have a single fraction on one side, 0 on the other. Is this an equation we can solve? Yeah. What happens if you multiply over the denominator? What's 0 times anything? 0. Isn't this just like finding an x-intercept? We've talked a lot about how when you're finding when a fraction is 0, it's just when the top is 0. So we get negative 3. All right. That option is perfectly acceptable. You get your common denominator, you work it out. The other option, especially if you're looking at this and thinking, ugh, that is way too much. I don't think I can do that. The other option is to say, you know what? I don't like fractions. Let's get rid of them. All right, we have 3 terms. This one has a denominator of 2. If I want to cancel that, I have to multiply by 2. Okay, but if you do it to one term, you have to do it to everything. So I would have to multiply all of them by 2. Then that cancels out. Are all my fractions gone yet? No, we still have, this one has x minus 1. So now I need to take everything times. Each term gets it. In this term, they cancel out. What you're left with at this point is 2x minus 3 times x minus 1 plus 2x times 2 equals, I'm going to run out of space, 2 times x minus 1. Here, let me erase. Can I just erase this so I have more space? I think that'll make life easier. All right. So if I multiply that, in the first fraction I have the 2x minus 3 and the x minus 1 left. Second one I have the 2x times the 2 left. And over here I have x times 2, so 2x times the x minus 1. We can multiply it out. So we get 2x squared minus 5x plus 3 plus 4x equals 2x squared minus 2x. Isn't this pretty similar to what we had before? We just aren't worried about the denominators. If I'm trying to solve this, if I subtract over my 2x squared, they cancel. Negative 5x plus 4x, so negative x plus 3 equals negative 2x. I add my x, I get 3 equals negative x, so that means x is negative 3. Is that what we got before? Yeah. So, option 1, option 2. What do you like?
Option
2. Okay. So we can agree that while getting the common denominator works, it keeps everything, it's just more work. It's easier to multiply and get rid of our fraction. Now, one thing I want to warn you. You do need to check your answers. But all you have to check, if we are solving them by multiplying and getting rid of the fraction, you just have to make sure that when we go back, you're not getting 0 on the bottom. Okay, does 2 ever equal 0? No. What would make x minus 1 equal 0? 1. So I could even say at the very beginning, I know x can't be 1. Did we get 1 for our answer? No, so we're good. Negative 3 is the answer. All right. Let's look at another one. So this is all we're doing today. All the problems are just fractions. We have now agreed on a strategy. We're going to get rid of our fractions. I think it's sometimes helpful when you're writing these problems. I usually put parentheses around my denominator and I space them out a little bit just so it's easier for me to go back and show what I'm going to multiply by. Personal preference there. But can you tell me right now what can't be the answer to this problem? 5. And how do we know that? Right. Can't get 0 on the bottom. Because on the graph, what's going to happen at 5? Oh, you do too know. That's our solution, the x-intercept. When the bottom is 0, we get a vertical asymptote, right? So that's why it can't equal 5. All right, term by term. If I want to get rid of this denominator, I have to multiply by x minus 5. If I do it on one term, I do it to every single term. That's each thing separated by addition and subtraction. So then, these cancel, these cancel. Do I have anything else I need to multiply by? No, I already got rid of all my fractions, so this one's nice. Here I'm just left with a 5. Here I have 5 times my x minus 5 equals 5. So 6x equals, if I add over my 25, 30, into x equals 5. right. What's wrong with that?
It's not allowed.
We said x can't be 5, so what does that mean my answer is? That's why you need to be checking. You might get that for an answer, in which case we know it can't happen. It's no solution. All right. Any questions there? Let's keep practicing. Okay, can you tell me right now what x can't equal this time? 0. Yep, if you plug in a 0 for your x, you get 0 on the bottom. Okay, first fraction. If I want to get rid of my denominator, I would have to multiply by, so everything gets a 3x squared. Okay, so that cancels all of this. And it would cancel an x right here, wouldn't it? What cancels in this one? 3 and 6 could reduce, couldn't they? To just be a 2 on the bottom. All right, so my fractions are better, not totally gone. So looking at the next fraction, what do I have left that I need to multiply by? A 2. So if you do it to 1, you have to do it to all of them. It's an equation. Everything, every term gets multiplied by it. So that cancels this too, and it cancels that. So we got rid of all of our fractions. You're essentially just multiplying by your least common multiple here. All right, so what I'm left with, in this one we have a 7 times 2. In this one we have a 9 times a 3x. Over here we have a negative 13 times x squared. All right, so quadratics, we always get equal to 0, so I'll bring over my 13x squared. Now what do we do? Flip and slide. All right, looks like we're going to have a larger number here. So 182. All right, so what would multiply to 182 and add to 27? Grab a calculator if you don't have one. Yeah. So we divide our 13 back. So we get x plus 1, 13x plus 14. If we set those equal to 0, we get negative 1 and negative 14/13. At the very beginning, we said x can't be 0. So these answers are okay. You might get a couple answers, you might get 1, you might get nothing. Okay, so we always have to check. Any questions there? We're going to try a few more. Now, in general, we don't want the problem to be any harder than it has to be. So I would suggest factoring denominators when you can. Okay, x minus 2 I can't do anything with. 1 over x I can't do anything with. But over here, x squared minus 2x, what can you do? Can you tell me right now what can't be my answer? Positive 2
And 0.
and 0. Good. All right, so now we get rid of our fractions. So the first one has x minus 2, so everything would have to get multiplied by x minus 2. So these would cancel, and this x minus 2 would cancel. My fractions aren't totally gone. What else do we need? So let's take everything times an x as well. That cancels this x and that x. So now my fractions are gone. So what I have is the 3x plus 2 times an x. We have the 1 times an x minus 2. And over here we just have negative 2. Or if you go ahead and multiply that, 3x squared plus 2x plus x minus 2. Right. Combine like terms. So we get 3x. When I add my 2 over, those cancel. So now what could we do? And that leaves us with x plus 1. So what do we get for our answers? 0 and negative 1. Are both of those okay? No, at the very beginning we said it can't be 2 or 0. So 0 doesn't work, negative 1 is the only solution we have. All right, how are we doing with these? Are you guys understanding our strategy? Factor your denominators first if you can. That way, you know, if I hadn't factored, I also would have been multiplying everything by an x squared minus 2x, and it just would have given me a bigger, nastier problem to solve. So factor so that you can cancel as much as possible. Why don't we try this one together, then I'll give you guys one to try. What should I do first? Oh, it's not that bad. What did I just get done saying? Factor. Okay.
Oh wait, no, negative 5. Sorry.
Has to multiply to positive 6, add to negative 5.
Negative
3.
Yeah.
X squared minus 4. X plus 2, x minus 2. Difference of squares. Over here, the x plus 3 on top. What can I do on the bottom? What should I do first?
No, take that 2 out.
Yeah, if I take out a 2, okay, so I have a 2. What multiplies to negative 6 and adds to negative 1?
Negative 3.
Okay. So just on this one, we just have more front end work. We had to factor our denominators first. Now we can decide, what can x not equal?
Negative 2.
Can't equal a negative.
Plus minus 2.
Yeah, we can't have a negative 2, we can't have a positive 2, and a 3. So none of those answers will work. At this point, we are just trying to cancel things out to make our life get easier. My first fraction has x minus 2 and x minus 3. So all 3 fractions get multiplied by both of those. That cancels all of this denominator. Cancels the x minus 2 in my second fraction, and the x minus 3 in my last fraction. So the first one is good. Second term, what does it still have on the bottom? So now everything has to get multiplied by an x plus 2. So that would cancel off the middle fraction and the last one. Okay, go to my last fraction. What's still on the bottom? So now everything just needs a plain 2. And that will cancel. All right, so let's see what we have. Is it okay if I go ahead and just multiply at least like my 2x and my 2? I'm trying to show you my work here, but that would be a 4x, and we still have to multiply the x plus 2. Okay, second fraction, if I take my 1 times my 2, I get 2, and we still have an x minus 3. And over here we have x plus 3, x minus 2. At this point, we have done all the hard work. This is an equation we would have solved last semester. We're just multiplying and combining like terms. 4x squared plus 8x, 2x minus 6. If I FOIL over here, that's x squared plus x minus 6. Okay, we always set our quadratics equal to 0. So I'm going to bring all this stuff over. So we get 3x squared, 8x plus 2x minus 1x, be plus 9x. Leaves us with x plus. So what do we get for our answers? Check our list. We couldn't have 2, negative 2, or positive 3. Are my answers okay?
Yeah.
Yes, so we keep both of them. Any questions there? I want you guys to take a minute and try this one. This will probably be our last one. Looks like we are on the right track. Everyone factored. Can you tell me what x can't be?
Plus minus 7 and 0.
Good. All right, so for the first one, you would have to multiply by x and x minus 7. So those are gone. My x minus 7 is gone. What else do we need? Mhm. Okay. So we have 4 times the x plus 7 minus 1 times the x equals 0 times anything is still 0. So we get 28 over 3. What questions? You just said you messed up.
I said I thought I messed up.
Oh,
We got negative 9 repeat. Because it was, because you take 20 divided by.
You said that
Oh.
wrong, bro.
you just did the decimal.
0.3.
Yeah, he said that wrong.
All right. What I want you to do now, there's a math Excel, so I want you to try it and ask questions.